Hey guys, as the name suggests, this video is going to be an introduction to storage. This is mainly for beginners and people who are working with different storage teams but have no idea about what is happening where. I'd like to begin with what is storage technology and why do we even need it? Storage technology, in terms of IT, is a place where your data is kept, stockpiled, or simply put or held, temporarily or permanently. Now, it is mostly described as data storage, and which is nothing but your data or information kept in digital format to be retrieved at some later point of time. So, since we are talking about what storage is, there definitely have to be some devices that are going to hold your data. Just talking about storage devices or media or medium are nothing but computing hardware that are used for storing, porting, and extracting data files or objects. It can hold and store information both temporarily or permanently and could be internal or even external to the computer or server or any similar computing device. Storage devices are mainly of two types because there was some storage that was internal to the system and there was some external to the system. Some was large, some was small. So we decided to divide these into two things so that it's easy for people to differentiate. So there are primary storage devices and there are secondary storage devices. Your primary storage devices are usually internal to the computer or server and hold data temporarily. Though they are faster, but they are smaller in capacity and hence cannot hold large amounts of data. A secondary storage, whereas, is larger in capacity, can be both internal or external to the system, and can hold data both permanently and temporarily. This is usually not as fast as your primary storage, but the way things are changing, we are going to have anything in future. Flash disks are actually going to change a lot of it in future. So some of the examples of primary storage can be a RAM and cache, whereas for secondary storage it can be your hard disks, USB, CDs, etc. So when we have this small thing to explain what storage is, why did we jump on to larger storage technologies? What was the need to jump onto such large technologies? We'll talk about that, but before that, let's talk about the measure of storage and data capacity. Yeah, we talked about storage, we talked about primary storage, secondary storage, you know, but then what is the measure of that capacity? How do you actually measure what amount of your data is kept anywhere in any device? So, the major terminologies that we used for measuring storage were bits and bytes. One bit is basically a binary digit that has 1 or 0. So, particularly a 1 or a 0 make a bit. 8 bits combine and make a byte, whereas when we keep on going further to next kilobyte, 1 kilobyte is equivalent to 1024 bytes. 1 megabyte is equivalent to 1024 kilobytes. Then comes 1 gigabyte, 1 terabyte, petabyte, exabyte, zettabyte, yottabyte, prontobyte, and finally 1024 brotabytes are equal to 1 geobyte, which is the highest memory capacity measure that we know about till date. Though we can have many more going forth as the amount of data is increasing. So, yeah, we were talking about why storage grew so much because the world grew so much. We were happy with the way things were, initially, but then the data, the information, things grow so much that storage became a domain in itself. The simplest answer is going to be exponential growth of data to this. If it's just impossible for simplest internal storage devices to deal with so much data or information capacity, hence a lot of storage technologies came into picture which were directly attached storage, leading to network attached storage because of its limitations. Further, because of the limitations of NAS, we reached out to the big world of SAN, which is Storage Area Network. In this video, we are going to talk about DAS, NAS, and SAN, all three, and how they are basic requirements about each, and what are the basic architectures for each. But before we go on to that, there are some important terms that I'd like to talk about because I'm going to use them often and then it would become easier for you to understand these. The most important and most used is going to be fiber channel. Now, what is a fiber channel? A fiber channel is a high-speed network technology that is used to connect computer data storage. It is most common connection technology for SANs. Fiber channel's long distance capabilities and faster speed are making it quite appropriate to be used. But then comes iSCSI. iSCSI is Internet Small Computer Systems Interface, which is an IP-based storage networking standard for linking data storage facilities. This works over TCP/IP and is becoming increasingly popular these days because of the enormous capabilities it provides us. A node is going to be any device or server. A WWN is a worldwide name which is a unique identifier assigned to a particular FC device hard-coded in it by the manufacturer to the manufacturers by IEEE. WWPN is worldwide port name, which is assigned to the ports of fiber channel fabric. A host bus adapter, also referred to as a host controller, connects one host to other networking and storage devices. And we talked about WWN. So one WWN is assigned to each HBA of a server or any device. You cannot have two WWN numbers as same. They are going to be different globally. JBOD, as the name suggests, as the definition suggests, is just a bunch of disks piled up together. Then we talk about RAID. RAID is redundant array of independent disks. This is a technology of combining disks in a way so as to protect your data in the best possible manner. This is going to be the simplest definition of RAID. Though RAID is a big topic in itself, and every RAID type has its own advantages, its own disadvantages, which is going to be quite lengthy if we talk about in this. So I'm going to skip that. So for you, the basic definition is going to be it's redundant array of independent disks that is basically putting disks in a way to protect your data in best possible manner. SATA. SATA is Serial Advanced Technology Attachment. It is working over serial signaling technology and hence this name. Other technologies usually work on parallel signaling. So talking about DAS, Direct Attached Storage. So as the name suggests, it is directly attached to the server, designed to be used only by one computer or server. So this does not mean that it's always going to be internal to the computer. We can have them as external as well. So, but the important point about direct attached storage or DAS is that it does not use storage network. I re emphasize that it does not use storage network. Although a common example of direct attached storage can be your internal hard drive, but more commonly we refer it to as a dedicated storage system. So, this pops up with another thing, which is its advantage. So, this kind of structure, which is DAS, direct attached storage, which is dedicated to a particular server, is quite advantageous for mainframe and OLTP type of applications where we have high data, uh, high data intakes and outgoings. So, DAS can be external as well, as talked about earlier. So, that can be, it can be attached to a JBOD enclosure or to a RAID enclosure. The main interfaces and protocols that DAS works with are SATA, eSATA, which is external SATA, serial attached SCSI, which is also referred to as SAS, and fiber channel. But then DAS was not enough for the growing needs of technology. For DAS, we could just, attach storage to a particular server as much as we wanted and use it. But then we could not share all this among others. So a limitation was that it could not be shared between multiple servers and hence it limited the capabilities of technology. Then came network attached storage, which could be shared to other servers over the network. Network attached storage devices connected storage to a network where they were accessed through file shares by multiple systems you have given permissions to. So, network attached storage or NAS devices supported Ethernet connection and they typically allowed the admin to manage disks, set disk quotas, provide security, and use snapshot technologies. These were using multiple protocols like NFS, CIFS, and SMB. So, NFS is used for your Linux systems, CIFS is used on your Windows system, and SMB is a technology that is used to convert your data type of Linux to Windows. But this technology in itself had a disadvantage. Since it was over the network, it was very, very low in speed and was throwing so many latencies that it could not be thought as a good way for uh, read write intensive applications. So, a typical example of network attached storage is shown here in this diagram where there is a storage that is connected to an Ethernet network switch and hence being accessed by servers over that network. But as I said, it had its own disadvantages, which led to the formation of storage area network, which is a big, big technology in itself. A storage area network or SAN is a dedicated network that allows one to share storage between multiple servers and data here is stored in volumes, which is also referred to as blocks. Hence, SAN is typically sometimes called as block storage as well. A SAN consists of storage devices, the interconnecting network infrastructure, which is switches mostly, and the servers that are connected to this network. So we have a particular zoning which dedicatedly allows the network to just share storage. SAN devices provide continuous and fast access to large amounts of data, and the communication and data transfer mechanism for a given deployment is coming through storage fabric. So, as we talked about switches in the last line, so storage fabrics are basically those switches that are giving this dedicated connectivity. A SAN uses separate network and is generally not accessible by other devices in the local area network. A SAN can be managed by using simple network management protocol, which is in our day-to-day lives called as SNMP. We hardly remember the full forms. So it is basically a proprietary management protocol which offers us the alert management. So SNMP is the one that is working over TCP IP and is going to send you the basic alerts that, hey dude, something's wrong with your SAN. Probably a disk failure or some communication issue, or any kind of errors being thrown by any servers on the particular fabric, and so on. A SAN does not provide file abstraction, it only provides block level operations. For file level abstractions, we have NAS. The most common SAN protocols that are used are iSCSI, Fiber Channel over Ethernet. A proprietary management protocol can deliver additional capabilities such as disk zoning, mapping, masking, and fault management. Now, what is disk zoning? Disk zoning is basically creating a particular network, a dedicated network for storage device and the server to communicate. These masking and mapping capabilities are basically bringing everything together to create this infrastructure for SAN to talk with a particular server or computer. So here's one example, where we have put a mainframe server, a Unix, a PC server, and there's this SAN infrastructure which has its ports, its zoning in place, and a lot of other factors depending upon the storage vendor that we are dealing with. And these servers could be Unix, could be Windows, could be mainframe, could be anything. They just need to have HBA, which needs to have its WWN to put it up in SAN network and make it talk to the storage over a dedicated network. So basically, storage area network is what most of the people are dealing with today and is a wide technology to talk about. Has n number of vendors, n number of products. The basic working remains same, but every product has its own pros and cons. Now, I told you that SAN works over network, storage area network, and NAS also works over network. But NAS was a file storage and SAN was a block level storage. So let's talk about the differences between the two. So these appear similar because they both bring together storage and network technologies to ensure that data storage is easily accessible, secure, and manageable. However, I'll make it clear they are totally different technologies. They are just not one technology. So NAS is directly attached to your internal network and is usually optimized for file serving purpose only. A SAN is a complete separate network that is dedicated to storage devices, traffic, and it's a block level device. Provides greater flexibility, additional functionalities, and it works over SCSI, iSCSI, fiber channel, or FCOE, which is fiber channel over Ethernet. Whereas NAS works on CIFS, SNMB, NFS over Ethernet network. But see, despite of the differences, the technology has grown like enormously, and hence there is a difference between SAN and NAS, but they blend together so well these days that so many NAS provide support for iSCSI and so many SAN provide support for SMB and NAS file systems. So that is how we are evolving. This is going to be too much to explain today, because this particular video was for just beginners, and if you're going to digest this, then trust me, you'll be able to understand the major concepts of SAN, NAS, DAS, or storage in itself to deal with more things. To connect with me, you can drop me your suggestions at techgirl23591@gmail.com. And so this was my first take on the simplest topics for beginners, but you can reach out to me on my mail ID with topics that you'd like me to take up in next lectures, with improvements, with any suggestions that you have. I'll be happy to hear back. Thank you.